Hello and welcome back to our subject, Digital Signal Processing System. So last meeting we discussed digital to analog converter using weighted resistor. So another way of converting digital to analog signal is using the R-to-2R ladder digital to analog converter. Alright? So what we have here is a 3-bit R-to-2R ladder converter. So the input is represented by S2, S1, and S sub 0. And the output is represented by V sub 0. Again, we are using here an inverting operational amplifier. Okay? Now, as we all know, the data coming from your DSP or digital signal processing or processor, will enter into your digital to analog converter. In this case, the R to 2R ladder circuit. Now, this input signal will be placed in your S2, S1, and S sub 0. So, assuming that your digital signal coming from your DSP or digital signal processor, S2, S1, and S sub 0 is equal to 1, 0, 0. Okay? So if S2 is 1, that means that this switch here is connected to your source. Okay? So it is connected to your source. And if S1 is 0, that means that this switch here is connected to the ground. And again, SO is 0. That means that this switch here is again connected to the ground. So that will be the setup, or that will be the status of your circuit. Okay? So for us to be able to determine the value of your V sub 0, we have to redraw the circuit, excluding this particular area here. We will add this on the end part of our circuit. No? So for redrawing, so since if you notice that this 2R here is connected to the ground, so we will draw it like this. You have ground, this is your 2R. This one here is your point A. Okay? Then we have here another resistor which is connected again to the ground. Okay? So let's have a common ground here. Okay? Oh, that one. So this one here is 2R, which is this one here. Then, at point A, there is a resistor connected. So this one here is point A. So this is another resistor. Or let's say, we transfer point A here. Okay? So this is your point A. Another resistor is connected. We name it as R. And then, another resistor, 2R, which is connected to the ground. So you have here point B, this one here. Then a resistor connected to the ground. Okay, and then this is again your 2R. Then your R here again. Okay, from B, you have R. And then point C. Then you have 2R connected to the source. So you have 2R connected to the source. Okay? So you have 2R. This is your R, which is this one. And then another 2R here. Okay, again, as I said earlier, let us disconnect this part of your circuit. Okay? So this will be your VR, alright, which is connected here. So this one here is point C. Okay? Now, if we will determine the value of your R here, if you notice that this 2R here are connected in parallel. So, let's say we represent it with R sub 1. R sub 1 is 2R in parallel with 2R. This one here and this one. Okay? So, R1 therefore is equal to 2R times 2R, a parallel man, over 2R plus 2R, which is 4R. So you will have 4R square over 4R. Okay? Cancel ang R. Cancel ang 4. So R1 therefore is equal to R. Okay? So these two here, two parallel resistors are equivalent to R. Okay? So we will redraw again. So the circuit now becomes this one. No? You have R, another R. Okay? This one here is your R1, which is equivalent to R. And then you have here another R, which is this one here. Okay? So this one here is your point B. Right? Then, connected to point B is 2R. Okay? Then, R. Okay? Which is this one. Then, point C. And then, connected to point C is your R and your voltage source VR. Okay? That is your VR here. And this is your point C. Okay? Point C, you have 2R. Alright? So that becomes your circuit. So since R and R here are connected in series, so you will have, by the way, this one here is your 2R, which is this one, and this one here is your R. Okay? And this one here is your 2R. So again, since they are connected in series, so you will have this circuit. Okay? This is your 2R. And you have here your 2R. Okay? R plus R is 2R. And then you have R. Then 2R. And your VR. Then you have again your 2R. Alright? So again, these two resistors are connected in parallel. So let's say we represent it with R2. So R2 will be equal to 2R times 2R over 4R. So again, the result is R. Okay? Can you follow? The same procedure here. So the circuit now becomes, again, this simplified circuit here. So you have R here, which is your R2, and then your R. And then this one here is your point C. So you have 2R. Okay, so you have 2R. Okay, then the source VR. Okay, and then 2R. Right? So again, these two are connected in series. So you will have this circuit now. Okay, so this one here, R plus R is 2R. And then you have here 2R, 2R. and then plus minus VR. Alright? So, since we have here now your VR, we can now determine the voltage drop across your 2R here. This one. So, we will have to redraw again. Okay? So, you have, we will transfer VR here on the side, on left side. Okay? Then, you have 2R. Okay? So, take note that this one here is point C again. So, you have point C. Then, you have here your 2R. Okay? So, this one here, ato sana siyang i-remove, kaning 2R. Ato sana siyang i-exclude, no? So, this one here, you have plus minus VR. And this one here again, 2R. Okay, which is this one. 2R na siya. So, if we will try to determine the voltage drop across your 2R here, which is represented by V sub 1, V sub 1 will be therefore equal to what? Okay? Plus minus V sub 1. V sub 1 using voltage divider. The voltage V sub 1 will be equal to the voltage of the resistor connected to the ground, which is this one here, 2R, over the total resistance, 2R plus 2R, which is equivalent to 4R, multiplied by VR. Okay? So that V sub 1, therefore, is equal to, cancel ang R. Okay? Then, divide by 2 is 1. Divide by 2 is 2. Okay? So, 1/2 VR, or V sub 1 is equal to VR over 2. That is your V sub 1. How about the total resistance? If you notice that this, if we will determine the total resistance, we will make this shorted. Kani? Ato ni short. And then that means that if it is shorted, that means that 2R and 2R will now be connected in parallel again. So, the total resistance, therefore, will be equal to 2R in parallel again with 2R. Which is, as we know, equivalent to R. Okay? The same procedure diri. No? Kaparallel man siya. So, the total resistance will be equal to R. So, therefore, if we will redraw the circuit now, so you will have the source, okay, which is equivalent to V sub 1, that is VR over 2. We have plus minus, and then the total resistance R, okay, in series with your 2R here, this one. Okay? Kaya mo, wala man na ito siya na-appeal ganiha, no? Kani siya, wala man na-appeal. So, we will now include it here. Ato na siya i-appeal diri, which is this one. So, you will have 2R. Alright? Muna siya ang kaning kaganiha. Wala na ito gi-include. Okay? So, kikuha mo na ito total resistance. So, i-add na ito siya karon sa 2R. So, this one here, the total resistance RT is R. Okay? Then, we connect the op amps. Okay? You have the minus, plus. Then, the feedback resistor, RF. So, you have here your VO. This one here is connected to the ground. Okay, so this is your RF. So, assuming that the current flowing here is I1, and the current flowing here is IF. So, we know that I1 is equal to what? VR over 2 divided by the total resistance. R plus 2R is 3R. Okay? And then, that is your current I. Or current I, therefore, is equal to, or I1 is equal to, what? The 2 here will be placed under. So you will have VR over 2 times 3 is 6R. That will be your I sub 1. And we know that I sub F here is also equal to, since it is connected to the inverting part of your op-amp, so you have minus VO over RF. Okay? And we know that I1 is equal to IF. This one. I1 is equivalent to IF. Right? So, I1, which is equal to VR over 6, is equal to minus VO over RF. So, if we will try to solve for VO, VO will now be equal to minus VR over what? VR, and by the way, this is what? 6R. Okay? So you have VR over 6R times RF. Alright? So cross multiply. So you have VRRF minus 6R. So that will be your V sub 0. Okay? Or the output voltage for this particular condition of your digital. No? 1, 0, 0. This will be your output voltage. VO is equal to VR RF over 6R. No? So, absolute value. No? So, it can be a positive value. Now, let us say, let us substitute a particular value in your VR, RF, and your R. Okay? So, let's say, let VR equal to 6 volts, for example, and then R is equal to 5K, and RF is also equal to 5K. Alright? So, what is VO therefore? VO will be equal to minus VR, which is 6 volts, times RF, which is 5K, over 6 times R, which is 5K. Okay? So we cancel this one. 5K, 5K, 6. 6 divided by 6 is 1. So VO therefore is equal to minus 1 volt. So that is your value of your VO for this particular condition of your digital. No? 1, 0, 0 coming from your digital signal processor. Once it passes through an R to 2R ladder converter, your output becomes 1 volt, no? Or minus 1 volt. So that is how the digital signal is being converted into its analog equivalent. No? So for this value, for this particular digital signal, with this value of R, VR, and RF, VO will be equal to minus 1 volt.